sequences, the general information is that you have a domain. Domain is still like our x values. So if you need to, you can remember it as your x values. The only difference with this domain is that you start with all natural numbers starting with 1, and all natural numbers are whole numbers. If you think about it, when we count, we don't count 0, 1, 2, 3, 4, 5. What we do is we count 1, 2, 3, 4, 5. So that's the main difference between sequences and any other functions we've been working with. And all a sequence is just a set of numbers in a pattern. And looking at the pattern is going to tell you the type of sequence it is, if it's arithmetic or geometric. So arithmetic is what we're going to start with. For arithmetic, you have D, which is a common difference. So what that means is that's really just the number that you add or subtract every time. So what are you doing every time? Are you adding a number or are you subtracting a number? And it's going to be the same common difference or the same difference within the numbers every time. For the arithmetic, you have the recursive formula or you have the explicit formula. The recursive formula is one that you can only use if you know the previous term. So if I wanted to know term 4, I'd have to know term 3. If I want to know term 10, I'd have to know term 9. With the recursive formula, you have to know your first term, because if you don't know your first term, you don't know your second term, and so on. So you need to make sure that you have both of these written for your formula for the recursive. A sub 1 is how the first part's read, and all that means is the value of the first term. So A really equals just your value, and the sub number represents the term number for that one. You also need to have A sub n, so the value with respect to n, so 1, 2, 3, 4, and so on, because remember they're whole numbers, equals A sub n minus 1 plus d. So what that means is the value of your given n equals the value of your previous n plus whatever you determined was your common difference. For the explicit formula, this one is going to be probably more familiar to you just because we've worked with a formula similar to this with y equals mx plus b. So for the explicit formula, you have a sub n, again, same thing there, equals a sub 1. So you take your first term and you add your common difference, multiplying it by n minus 1. And what I've told the kids, and I'll show you in the next slide, is go ahead and actually distribute it out and simplify it down so it looks like a formula that we've used in the past. So here are some arithmetic examples to help you. If you first look at A, 1, 3, 5, 7, 9. So what I'm doing every time is I'm adding 2. So what I'm going to do is write D equals 2. And that just tells me that my common difference is 2. So if I were to write the explicit formula for this one, I'm going to start with A sub n equals my first term, which is 1, plus my common difference is 2, times n minus 1. And again, what I've told the kids is go ahead and just distribute everything out and simplify it down. So A sub n equals 1 plus 2 times n is 2n minus 2. So 1 minus 2 is going to give me a negative 1. So really the explicit formula is negative 1 plus 2n. Now, if you just kept it as the first part we wrote, A sub n equals 1 plus 2 times n minus 1, that's okay. You wouldn't get anything taken off for that. Now, go ahead and make sure you have this written down. If you need to pause the video, go ahead and pause it, because what I'm going to do is I'm going to erase it now, and we'll go over the recursive formula for it. Okay, now we're going to write the recursive formula. So for the recursive formula, remember I said you have to have two parts. You have to have your A sub 1, so in this case my first term is 1, and then I have A sub n equals my previous term, so A sub n minus 1 plus my common difference, which is 2. And that's as far as you can go for the recursive formula because you don't know what term you're trying to find. Now, if they asked to find term 2, you could do that, or term 3, you could do that. And I'm going to show you with the next one how that would work. So let's look over at B now. For B, what am I doing every time is I'm actually going down 2. Well, instead of subtracting 2, I can also say that I am adding a negative 2. So again, the common difference is the same thing. I'm subtracting 2 every time. So for the difference, I'm going to put a minus 2. Again, adding a negative is the same thing as subtracting, so we're okay there. And I'm going to write the recursive formula first. Let's do that one. So I'm going to have my recursive. Remember, you have to have your first term. So a sub 1 equals 12. And remember, a is the value, the sub number is the term number. So the value of my first term is 12. Then I'm going to have a sub n equals a sub n minus 1. And because it's a sub, you want to write it lower than your actual letter value. And because I'm subtracting 2 every time, I'm just going to write minus 2. Now, you could write a plus negative 2. That's completely fine. You would never get taken off for that. So go ahead and make sure you have this written down, and I'm going to go ahead and erase it and do the explicit formula. Okay, for the explicit formula, I have a sub n equals my first term, which is 12, plus a negative 2 times n minus 1. So I'm going to distribute everything out. So I have a sub n equals 12 minus 2n plus 2, because a negative 2 times a negative 1 gives me a positive 2. So I'm going to combine like terms. So my explicit formula is a sub n equals 14 minus 2n. So now let's say I wanted to find the 15th term. What would the 15th term be? So in order to find that, what I would do is I would plug in a sub 12. So the value of my 12th term equals 14 minus 2 times 12. And then whatever you get for that answer, so 12 times 2 is 24, so 14 minus 24. So the value of my 12th term is going to be a negative 10. And this right here would be my answer. Now we're going to look at their geometric sequences. So the difference between the geometric and the arithmetic is that with geometric you have what's called a common ratio. So what is it being multiplied every time? Now with that, if you want to write that down, so it's what's being multiplied each time. Now that can be a whole number, or if we're dividing, let's say dividing by 2, that's the same thing as multiplying by 1/2. So like in the arithmetic ones, we have plus a negative. Well, instead of dividing with our common ratios, we're just going to multiply it by the fraction. So if you need to write that down in your notes, make sure you do that. Now we have the explicit and the recursive formula. The explicit formula is a sub n equals a sub 1, so remember that's the value of our first term, times r, which is our ratio, raised to the n minus 1 power. For the recursive formula, we have a sub n equals a sub n minus 1 times r, and remember we also always have to have our first term, so we always have to write down a sub 1 equals. And again, r is the ratio, so it's what's being multiplied every time. Alright, so now what we're going to do is we're going to do 2 examples for geometric sequences. If you look at A, what I'm doing every time, 2 to 4, 4 to 8, and so on, is I'm multiplying by 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on. So I'm going to write down r equals 2. So for the explicit formula, I'm going to have a sub n equals our first term, which is 2, times our ratio, which is 2, raised to the n minus 1 power. And that's as far as I can go because I don't know what n or what term number we are solving for. For the recursive formula, I'm going to have a sub 1 equals our first term, which is 2. Then for the other part, a sub n equals a sub n minus 1 times 2. And that's as far as I can go there because, again, I don't need to do anything or solve for anything because I don't know what I'm solving for yet. Now, if we look at example B, 27, 9, 3, 1, well, you could say I'm dividing by 3, which in fact I am, but remember from the previous slide, we're not dividing anymore. We're multiplying. So the same thing of dividing by 3 is going to be multiplying by 1/3. So I'm going to have my R equals 1/3, and I'm going to have, for the explicit formula, a sub n equals my first term, which is 27, times 1/3 raised to the n minus 1 power. For the recursive formula, I'm going to have a sub 1, which equals 27, and then I'm also going to have a sub n equals a sub n minus 1 times 1/3. So let's say I wanted to find the third term, just to show you. So I would probably use my explicit formula, but you could use either one. And all I'm going to do is put in a sub n. Actually, I'm going to change that n because we want to find the third one. So I'm going to do a sub 3 equals my first term, which is 27, times 1/3 to the n minus 1, so raised to the 3 minus 1 power. So that's really 27 times 1/3 squared. So really what I'm going to do is do that in my calculator, and I should end up with a sub 3, so my third term equals 3. And again, you could do it to find any term value with the explicit formula. I hope this helped a little bit. If it doesn't, please let me know and I can put some more examples online for you.